Hello, and welcome to our ME611 Modern Product Design Final Project. We'll be going through the design process case study of a hand mixer. My name is Nicholas. I'll be joined by my teammates Devin, Eris, Laura, and Logan. Here's an overview of our presentation. We'll start with an introduction and problem statement, move into our methods, our results, and a conclusion.
In order to design a successful product, the design process needs to be fully understood and applied. To achieve this, we'll be using a structured process, which begins with identifying a problem, understanding customer needs and requirements, concept generation, screening, selection, and so on. For our project, we'll be using a hand mixer as a subject for our case study. To start with our problem statement, existing hand mixers are typically loud, uncomfortable, and hard to clean and messy.
To start collecting our customer needs, we first analyzed existing products and their customer reviews and online videos to understand the reputation that the existing products have and how they're handled by our customers. After that, real-life candidates were questioned strategically to nail down the customer requirements while avoiding to make assumptions on ourselves. Our market analysis concluded that our target group is the lower base of the economic pyramid, aiming to address the hobby home baker as well as the older generation. Professional home chefs and bakers who also would be interested in our highly efficient and well-designed product are counted to our secondary customers. Our customer interview questions included asking about the customer's typical use scenario, what they liked and disliked about their current product they're using, where they see room for improvement, and what the product is used for. From 11 interviews, we were able to gather 33 customer needs that could be divided into 6 affinity groups, such as aesthetic, ergonomics, and usability.
The next step was to develop the Quality Function Deployment, or QFD. QFD is a process and set of tools, including the house of quality shown here, used to help define and translate customer requirements into engineering specifications and measurable design targets. We started off with 10 customer needs gathered from the interviews and 15 engineering specifications to help meet those needs. Next, we moved into the relationship matrix of how the needs and specifications interact and are meeting those needs. The roof of the house is made up of interactions between the engineering specifications and how meeting one affects the others. On the far right, you can see the 5 competitor benchmarking matrix with all of the competitors scored on how well they meet the different customer needs, including Cuisinart, KitchenAid, Hamilton Beach, Avente, and Sunbeam, which were found to be large portions of the market. Lastly, we have our target values on the bottom for each engineering specification, taken from those benchmarks, as well as customer interviews and customer reviews found online.
After identifying our target values, we started concept generation using 5 main approaches: brainstorming, biomimicry-inspired design, C-sketching, morphology matrix, and the theory of inventive problem-solving, or TRIZ. These 5 approaches yielded 17 total concepts, but 7 top concepts. Our 5 main ideas were structured around the actual shape of the product. These designs all included variable types of features, such as battery or corded, different types of attachments, using splash guards in certain places rather than others, different handle grips, and different cleaning styles.
After the initial concepts were generated in the first round of concept generation, pew charts were used for both feature and concept screening. Pew charts are a very quick method of screening decisions based off of customer needs, using rankings of positive or negative quality when compared to a chosen datum concept. This analysis was for deciding on a input device or input structure for the hand mixer, and in this analysis we found that the slider was the best concept chosen for that. Similarly, pew charts were used for actual concept screening, which resulted in concepts F, D, and C being the highest ranked. These 3 concepts were used to then generate hybrids, which use the best features of the selected concepts to create better ones. Concept F was ranked highest in durability and comfort, which set it apart from the other concepts. These hybrids were then evaluated using a weighted decision matrix, which resulted in hybrid concept C2 winning out, which was similar to concept C, but with lights for easier viewing and a couple ergonomic improvements. And then with this concept screening, we then moved on to the initial modeling.
So the results of our case study show that market analysis displayed a clear forthcoming growth in kitchen appliance industry, meaning that our product would go into a market that is growing and would receive it well. Next, customer interviews give insight into the needs of those customers and ensure that we assigned proper values to the different specifications that would help meet those needs. These clear measurable engineering goals come from the house of quality which also serves as a visual aid in demonstrating the interactions between the engineering specifications and how well they meet those needs. In our concept development stage, we developed 17 solution concepts, with 7 of them fully developed to then be used in the next stage of Q charts for screening and scoring, and a decision matrix to help select those concepts. On the right, you can see a final design of our CAD module, which will be discussed in the next slide.
Taking a look at our final product, the first feature we like to highlight is the extending bull arms, which allow the user to easily pick up and move the device. Next are the intuitive controls, which include the on-off buttons, timer display, timer controls, and the speed slider. Third are the mixing pegs, which are removable in order to make cleaning easier. Fourth is the retractable cord, which make for easy and condensed storage. And lastly is the rubber base, which provides the stability and noise dampening.
In conclusion, the product design process is what you make it. The more you put into it up front, the more you can get out of it and benefit yourself later in the design process to have a more fully developed product that meets needs better. The directed activities and tools help considerably in this process when creativity can be a limitation on what kind of concepts you develop and different engineering solutions to meet those needs in more creative ways. Lastly, we learned that good design is holistic and that it's more than just engineering. Our design team consists entirely of engineers and doesn't have all of the expertise going into the product that an end user might have, such as the home baker who it's trying to reach. So designing for that up front and interviewing properly, gathering more needs, helps us to define the process so that we meet those needs better in the long run. And here are our sources. Thank you.